now we can actually do an experiment to show that molecules diffuse through water. And for such an experiment, we require the following materials. The first one is a beaker, some amount of water, I pour some amount of water into the beaker.
Good morning, Ye. Good morning, Bamlak. How are you doing today?
We are doing fine, thank you. How are you doing yourself, Sorani?
I'm doing fine too, thank you. On my way here, I was thinking about observations that I've made. Whenever I come home from school or elsewhere, I know that food is being cooked on the stove without even looking at it.
Oh yes, you're right. I've frequently seen that if somebody puts a drop of a colored material, say a blue ink, on a glass of water, after some time, all the water in the glass turns blue.
And I have also observed that as our biology teacher enters our classroom, we all get the good smell of the perfume she wears. In fact, even the students at the back get the good smell.
Oh, I see that these are observations that we've all made. But what scientific explanation do you think we can give to this?
Well, we have learned that all things are made up of molecules. Therefore, the food, the ink, and the perfume are all made up of molecules.
Yes, that's right. But this does not explain the situations we've observed.
Yes, but we also know another fact. This is that molecules are always under a constant motion. They never stop moving.
Okay, but do the perfume molecules only move in the direction of our nose?
No, they move as random.
Okay, but what does random movement mean?
What I mean is that molecules always move in any direction. They can also come back to their original position. This is what we call the Brownian movement. But overall, they move from a region where they are found at a higher concentration to a region where they are found at a lower concentration.
Now I understand. We're actually talking about 3 points. The first point is that all things are made up of molecules.
The second point is that molecules are the constant random movements in any direction.
And the third point is that all molecules always diffuse from an area of a higher concentration to an area of a lower concentration. This is what we call diffusion. So right now we can actually do an experiment to show that molecules diffuse through water. And for such an experiment, we require the following materials. The first one is a beaker, some amount of water, I pour some amount of water into the beaker. And we also require some amount of food color. Sorani, would you please place some amount of food color into the glass of water I've prepared?
Of course, Malak. We don't have to mix it up. Now, let's wait for some time and see what happens.
The color is moving from the food color to the other parts of the water in the glass. This shows the movement of color molecules from a higher concentration of color molecule to a lower concentration of color molecule. Although molecules move in any direction, overall or net movement is towards lower concentration of color molecule.
I have a question. Does the movement of the color molecules stop after they're evenly distributed in the water?
No, molecules never stop moving. When one molecule moves in one direction, another molecule takes up its place. Therefore, even distribution is always maintained.
Well, we can also conduct a simple experiment to show that molecules diffuse through gas.
This is
Will you please spray this deodorant at the other side of the room?
certainly.
We now position ourselves at different sides of the room and raise our hands when we first get the smell.
I have got the smell.
I've also got the smell. I smell it now.
I also have another question. Why did we report different times of getting the smell of the deodorant?
Well, we've already said that molecules do not only move in the direction of our nose. Therefore, it takes some time for them to move away from the source. The person closest to the source, which was me, will get the smell first, and the person furthest from the source, which was I, will get the smell last.
In that case, from where do the molecules get energy to move from one position to another?
Well, I remember that our chemistry teacher has told us that molecules do not use up energy in order to move randomly in a Brownian movement. And this is why the diffusion is called a passive movement of molecules.
Well, we can now say that our experiment has supported our hypothesis, therefore we can accept the hypothesis.